Okay, so moving on from your homework, so after multiplying and dividing, we're going to move on to adding and subtracting rational expressions. Okay, so let's kind of jump back. So just adding and subtracting, but let's kind of step back a little bit and think back to our fraction rules. I'm going to get an expo marker here. Give me 1 second. Okay, so if I think about, and you can just add this to your notes page, you can write on a scratch sheet of paper. We're just going to kind of take a walk down memory lane here. So let's just think back to like good old school fraction work. We'll start with our review from last week. So when we multiply fractions, what are the rules? Well, I can just go straight across. So 1 times 3 gives me 3. 2 times 4 is 8. 3 over 8. See if I can simplify. I can't. So 3 over 8 would be my final answer. All right, similarly with division, 1 over 2 divided by 3 over 4. And this should all feel like a review from what we did last week. Okay, so very similar, but the only difference is this division. Fractions are already division, right? So it's like division on division on division. What happens with all of that division is I end up, the first one is fine because that's just one step, 1 divided by 2. But then when I divide 1 divided by 2 divided by 3 divided by 4, this is when everything starts kind of going crazy. So the first one I'm going to keep the same. The second one I'm going to change to multiplication. And then the last one I flip to 4 over 3, which is going to give me 4 over 6. So then the rules apply straight across for multiplication. 4 over 6, though, is a little different than 3 over 8 because I can simplify this. I can divide everything by 2. Which gives me 2 over 3 as my final answer for division. All right, that should feel very much like a review, not just from, back in elementary school and middle school, but also just from what we were looking at last week. Okay, now let's talk today just simple with fractions. Like what happens with addition and subtractions? Let's think if I do 1/2, we'll use the same fractions plus 3/4. Okay, let's say we're ordering some pizzas here. We have the same size pizzas. So I'm ordering a medium pizza and I don't know, somebody really cool, like, I don't know, Beyonce, sure, why not? She's also ordering a pizza the same size, okay? The issue, though, is, like, same size pizza. So if I eat the whole thing and she eats the whole thing, we've eaten the same amount, right? But then it's, like, a little tricky because my pizza I order cut in halves because, I'm going to fix that. It's going to bother me. So I want my pizza cut in halves because I'm just like, whatever. I'm just going to take a big old bite out of a half a pizza, all right? Beyonce is like, she's a little bougie. She's like, no. I need mine cut in fourths. All right, so same size pizza, same amount of pizza, but we're cutting it in different sizes. So like 2 represents how many total pieces, 4 represents how many total pieces, and then the one number on top is how many that we're actually eating. I eat one of my pieces, right? And I'm like, oh, Beyonce, I only ate 1. And she's like, oh, I ate 3. I feel like I ate too much, right? So like she eats 3 and I eat 1, but because our slices are cut differently, like there's no way for me to know like exactly how much we ate just by looking at this. Like I know that she ate a little bit more than me, right? But her pieces are cut smaller. So it's not like she ate 3 that are the same size as mine. So it gets really difficult to add and subtract fractions if our denominators are not the same. It's really hard to add and subtract numbers of pieces of pizza if the pieces aren't cut in the same way, right? So that's the first thing I need to remember when I add and subtract is I have to have common denominators. So I would add this in your notes, and it's going to get a little trickier as we move along. That's the first step is need to have common denominators. So let's come back to this question, 1/2 plus 3/5, okay? I want to know how much total pizza we ate together. So out of those 2 medium pizzas, like how much did we actually eat? What's left over so that I can kind of plan from there. So this was actually 3/4. Okay, so what I have to get common denominators? Well, this one's not so bad because 4 and 2, I can easily see what they have in common. Well, that's 4. So just multiply this one to get it to 2/4 plus 3/4. And that is going to give me 5/4. So this is different than multiplication. I don't add the denominators. The denominators actually stay the same because I'm not changing the total number of slices of pizza, right? That stays the same. I'm changing how much we actually ate. So we actually ate 1 full piece of pizza between the two of us and then 1 little fourth left over. So if both of our pieces were cut into fourths, oh, this is bad drawing, sorry. We ate 4 of them and 1 of the others, right? So we ate 1 and 1/4 pizzas all together. So now we can compare because we have common denominators. All right, so we'll use that same concept and get a little bit trickier. let's add in, let's say I have something like this, 1/2 minus 3/5. So basically the same thing, but now it's a little harder to get common denominators because I don't see 2 and 5. I can't immediately see anything they have in common. So when this happens, I just want to multiply them together. That's the easiest thing to do. 2 and 5, 10 is going to be the least common denominator. So I'm going to multiply this one by 5 and this one by 2. And that's going to give me 5 over 10 minus 6 over 10, which is going to give me negative 1/10. So not so bad. Just multiply them together if you can't immediately find the common denominator. All right, let's throw in 1 with exponents, and then we're going to try some together. 2 over 3x minus 4x over x squared. Okay, well, now we got some variables, but same concept, right? Check and see if you can simplify anything first. 2 over 3, nope. 4 over nope, x and x squared. Oh, I could try to simplify that, right? That might be helpful here. So let's see if we can go ahead and break that down. So x and x squared, I can simplify that because this is just multiplication over division, right? The subtraction sign is separating these out. So from here, I'm going to have 2 over 3x minus 4 over x. X over x squared. 2 minus 1 gives me 1x. And there's more in the denominator, so it's going to stay in the denominator. Okay, so this is a little easier. I don't have that x squared anymore. If I couldn't simplify, it would be okay. I could still just try to get common denominators there. So now let's see. First, let's see what they have in common. Well, I have an x in common, right? So that's a common denominator. But what does this one have that this one doesn't? A 3, right? 3 times x. So that means this one is missing times 3. Well, what I do to the denominator, I have to do to the numerator. And I get 2 over 3x minus 12 over 3x, which is going to equal negative 10 over 3x. Then you want to check, can I simplify this? 10 and 3, nope, that would be my final answer. All right, cool. Let's just keep practicing because that's what you need at this point is just lots of practice, and I'm going to give you some extra practice to do in the end as well. All right, let's dive in. So on your notebook, I'm on page 32. If you wrote some notes on page 32, that's cool. You can move on to the next page. Let's look at an example here. Okay, so I know I'm subtracting. This is a little different than multiplication and division that we did before. I also know that I have 2 terms on the top over 1 term. This term on the bottom needs to go to both of these. So I'm just going to separate it out. We've been doing this for a while. This isn't so bad. 56x squared y to the 4th over 8x cubed y minus 64x squared y over 8x cubed y. Please feel free to pause this if you'd like to try it on your own and then come back to check your answers. All right, so now I have a monomial on top and a monomial on the bottom. There's no addition and subtraction happening in this fraction, so I can simplify straight down. So I can say, okay, 56 divided by 8, what does that simplify down to? Well, 56 divided by 8 is 7. Remember, you always want to start with your numbers. And then I want to follow my exponent rules. So x squared over x cubed. What is the rule when I divide? I subtract. Well, I have more x's in the denominator. So 3 minus 2 is actually going to be 1, but it's going to be in the denominator because that's where I have more, right? So then similar, 4, y to the 4th over 1y is going to be y to the 3rd in the numerator because that's where I have more y's. All right, now I'm going to come over here to the second one. Do the same thing. 64 divided by 8 is going to be 8. X squared over x cubed is going to be 1x in the denominator. Y over y, those cancel out. And I'm just left with 7y cubed over x minus 8 over x. All right, now since I have common denominators, I can just write this as one expression. 7y cubed minus 8 all over x. And that would be my final answer. 7y cubed minus 8 all over x. All right, let's look at one that's slightly different. So if I do 15 over 2x minus 16 over 3x, well, this is a little different than it was up here because I don't have common denominators, right? So I got to figure out something a little bit different here. So before I can do 15 minus 16, I need to get the 2 and the 3 to match. The x's are cool, so I'm going to just leave those x's be. They're great. Let's just get the 2 and the 3 to match. Well, I can't find 2, I can't multiply to get to 3, so I'm just going to have to multiply those together. So I'm going to multiply the bottom by 3 and the top by 3, the bottom by 2 and the top by 2, and then I'm going to simplify. So 15 times 3 is going to be 45 over 6x. Minus 16 times 2 is 32 over 6x. Okay, now I have common denominators. So I can bring my 6x over here, keep the denominator the same, and subtract 45 minus 32, 13. 13 and 6. Can I divide 13 by 6? I cannot. So that would be my final answer, 13 over 6x. All right, let's look at example 3. So slightly different. I notice I have an a squared, I have an a. That's kind of good. I have something in common. But before I even do that, I could get common denominators at this step, 100%. But I actually noticed that I could simplify here. Why do you think that that would be helpful? Well, anytime I can simplify before I start all of this process, it's just going to make my life a little easier. So I'm actually going to go ahead and try to simplify this down here. So I'm going to get 4 over a squared is going to give me 2 minus 1 is 1a. Why is it in the denominator? Because I have more a's in the denominator. Minus 7 over 8a. Okay, this makes my life easier because now my a's match, right? If they didn't, I could just multiply by a over here. That would be fine. But now they match. So now I need to say, okay, well, what is this side missing? This one's 8a and this is just a. So this one's missing an 8 in the denominator, which means it also is missing it in the numerator. So now I'm just going to simplify. 8 times 4 is 32 over 8 times a is 8a minus 7 over, this one doesn't need to change at all, so 7 over 8a. Now I can combine my like terms. So I'm going to keep my denominator, and I'm going to do 32 minus 7. 25 over 8a. Okay, at this step, is there anything I can simplify? 25 over 8. Nope, there's nothing they have in common. I can't divide by any number. So my answer is just going to be 25 over 8a. All right, let's try one more before you try some on your own. Okay, let's look at this one. Now, this one looks a lot more confusing, but you guys know how to do this. You know how to break it down. What's confusing is like, this one has a k, this one has a k squared, this has a 12. Like, I don't really know what to multiply by, right? Like, I know this is missing a k somewhere, but it's going to be hard to look at it in this form. So when that happens, I want to simplify first. So let's see if I can simplify this down. Can I cancel out the k and the k? Nope. Not at all, because I've got this plus down here. So instead, I need to think factoring. If I can't cross anything out, I need to try to factor this down. So I'm going to say 2k. Nothing can happen to 2k. It's just a monomial. It's just by itself. Okay, so 2k is done. I can simplify the denominator. What's the GCF between 3k and 12? 3. So I'm left over with k plus 4. All right, k plus 7. Can I break that down anymore? Nope. All right, k squared and 4k. Well, I got two terms, so all I can do is check for a GCF. K squared and 4k, the GCF is going to be k. And I'm left with k plus 4. Oh, well, this is good. So now when I step back and I kind of look at my denominators now, oh, they both have a k plus 4 in common. I couldn't see that up here immediately above, right? But once I break it down, I know, ooh, GCF, they've got a k plus 4. Now I just need to focus on what they're missing. Well, this one has a 3 and this one has a k. So that means I need to send a k over here. What I do to the denominator, I have to do to the numerator. And I need to send a 3 over here. What I do to the number, I have to do to the numerator. Now they each have a k, a 3, and a k plus 4. A k, a 3, and a k plus 4. Excellent. My denominators are good to go. So I'm going to go ahead and write my denominators like this. I'm going to go ahead and put my denominators first. So I can do 3k, k plus 4, plus 3k, k plus 4. And I don't want to FOIL this out yet because I'm just going to leave it. I want to keep it as simple as possible. But I do want to go ahead and multiply this to the top. So when I distribute this, what's k times 2k? 2k squared. All right? And what is 3 when I distribute this? 3 times k and 3 times 7. I get 3k plus 21. Now, when I add, I keep my denominator the same. And I bring my numerator. So when I add, I just combine like terms. 2k squared doesn't have any like terms, so I'm going to go ahead and bring it down. Plus 3k plus 21.